This lesson is going to go through proving properties of special quadrilaterals. So we've already looked at parallelograms, and now we're going to look at special quadrilaterals. And if you recall from coordinate algebra, we've gone through these properties before, so we're going to go through them fairly quickly to get to the examples at the end. If we're talking about a rectangle, remember the rectangle has four, we should say congruent sides, or not congruent, I'm sorry, four sides and four right angles. So all of the angles are congruent because they're all right angles. A rectangle is a parallelogram, so that means all of the all the properties, the five main ones we talked about in the last lesson, hold true for a rectangle because it is a parallelogram. So opposite sides are parallel, opposite sides are congruent, consecutive angles are supplementary, opposite angles are congruent. Another thing to remember is that the diagonals they bisect each other. That's the property of a parallelogram, but in a rectangle the diagonals themselves are congruent. For a rhombus is a special parallelogram where all four sides are actually congruent. Again, because it's a parallelogram, all five of those properties hold true that we spoke about in the last lesson. And one additional thing to note is the diagonals bisect the opposite pairs of angles. So as I draw in my diagonal, these angles get bisected. Lastly, the diagonals of a rhombus, they form four right angles. And that would be shown right here. So basically the diagonals are perpendicular if it's a rhombus. Alright, so we've got a square. A square has all of the properties of a rectangle and a rhombus because a square is both a rectangle and a rhombus. So all sides are congruent, all angles are right angles, the diagonals bisect each other, the diagonals are congruent, the diagonals bisect the angles, and then the diagonals are also perpendicular. Trapezoid, remember we have two types of trapezoids. We just have the general trapezoid, and then we also have the isosceles trapezoid. So here we're just talking about a general trapezoid. So in a trapezoid, it's not a parallelogram because only one pair of opposite sides is parallel, not both. And the parallel sides are called the bases, so this is my base, BC and AD, and then the non-parallel sides are called the legs. We have an isosceles trapezoid. Again, since it's a trapezoid, only one pair of opposite sides are parallel, but this time the legs are congruent, kind of like the legs of an isosceles triangle. Since the legs are congruent, the base angles are also congruent, similar to what we talked about the legs and base angles of an isosceles triangle. The diagonals of an isosceles triangle isosceles trapezoid are also congruent. A kite, remember there are two disjoint or two distinct pairs of congruent sides. So we've got this pair of congruent sides and then this pair of congruent sides. They're not parallelograms, and in fact there are no opposite sides that are parallel. The diagonals of a kite are also perpendicular to one another. Here's my hierarchy of quadrilaterals, starting with just in general polygons, because we've got other polygons over here, triangles, pentagons, other numbers of sides. And we have specifically quadrilaterals with four sides. So all of these are quadrilaterals because they all have four sides. But then we have parallelograms, and in that category fall rectangles, rhombuses, and squares. And remember that rectangles and rhombuses, notice that they both point to square because a square is both a rectangle and a rhombus. So these are all my parallelograms. I do also have quadrilaterals that are not parallelograms, kites and trapezoids. Kites are sort of on their own, and in trapezoids we have trapezoids as well as isosceles trapezoids. So let's go through these couple of examples that we have. It gives us a or the vertices, excuse me, for my quadrilateral. So I'm going to plot those. Alright, so there is my quadrilateral, and I am trying to prove which one of these quadrilaterals it is. Sorry. So I'm going to look at the opposite sides to see if they are parallel. So let's look at the slopes of the opposite sides. We've got AD and we've got BC. Let's look at their slopes. We've got 1, 2, 3, 4 over 3. 1, 2, 3, 4 over 3. So these two are parallel. Alright, let's look at AB and DC. And we've got, let's see, 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6, 7, 8. So negative, which reduces to negative 3 over 4. And then 1, 2, 3, 4, 5, 6, 2, 4, 6, 8. Same thing. So these two are also parallel. Notice though that the consecutive sides, these two right here and these two over here, have opposite reciprocal slopes. So that means that this is either a rectangle or a square because we've got right angles since these are perpendicular. So let's check real quick and let's just look at the consecutive sides, and if they're the same, then it's going to be a square because that means all of them are the same, and if they're not, then it's just going to be a rectangle. So we've got, I'm going to do Pythagorean theorem. For this one I've got 4 squared and 3 squared, so that gives me 5. So my side length for this is 5. And then here I've got 6 squared and 8 squared, and then it's actually going to give me 10 squared, so this is 10. So because opposite sides are parallel and consecutive sides are perpendicular, we determine that it's a parallelogram, but we weren't sure if it was a rectangle or a square based on the fact that I have right angles here. But since consecutive sides or sides right next to each other are not congruent, then it has to be a rectangle. Alright, I'm going to go ahead and pause this and plot my points. Alright, so I've plotted my points. And let's look again at the slopes of my opposite sides. So let's look at AB and DC. AB, I've got a slope of negative 1, 2, 3, 4, 5, 6, 7. Negative 7, and then over 11. And then opposite side over here, negative, that's plotted this one wrong. Let's try this again. That looks a little bit better. Sorry about that. Okay, so I've got a rise of negative 7 and a run of negative, a run of 11. Alright, so we've got same slope here for those opposite sides. Now let's look at DA and CB. DA, my rise is 7, my run is positive 11. And CB, my rise is 7, my run is positive 11. So again, this shows that these are parallel. Now when I look at consecutive sides consecutive sides are not perpendicular, so we know it's not a square or a rectangle. So basically, it's a parallelogram, and it means it has to be either a rhombus or just a plain parallelogram. So let's look at the sides and see the distances or the lengths on them. Notice though, if you look at our slopes, all of our slopes are the same. Well, not the same, but the same numbers. So we've got 11 and 7. Here it would be 11 and 7. Here 11 and 7. And 11 and 7 as well. So when I look at this, that means that these all have to be the same based on the Pythagorean theorem. If all my sides are 7 and 11 of my right triangles, then these have to be the same as well. So then this would be a rhombus. So I could go through and actually figure out the hypotenuse for each of those. But that's not really necessary. It's going to be the square root of 170, but that's not that really necessary. Alright, the third one, we have this quadrilateral. Let's see, A, B, C, and D. So let's look at our slopes of our opposite sides. Alright, AB, we've got a rise of 1, 2, 3 and a run of 2. DC, 3 and 2. So these are parallel. Alright, let's look at AD and BC. AD, I've got a rise of negative 2 and a run of 1, 2, 3. Negative 2 and a run of 1, 2, 3. So these are parallel. Notice these are also opposite reciprocals, so we also have perpendicular, which means we've got right angles here. So we're looking at a parallelogram with right angles, so we're looking at either a square or a rectangle. So let's look at our sides. If each of these are 2 and 3, then the hypotenuses, which happen to be the sides of my figure, my quadrilateral, are also going to be the same. So all of the sides are congruent, which means that it is a square. Alright, we've got 0, 3, 5, 2, 6, negative 3, and negative 1, negative 4. Alright, so based on what I have drawn, it doesn't look as though opposite sides are parallel, but let's just check out just in case. So we got MA and HT. MA has a negative slope and HT has a positive slope. So that's not going to be parallel. So we know that they're not parallel. So we don't have a parallelogram, which means we're left with a kite or a trapezoid. If it's a trapezoid, then one pair of opposite sides is parallel. So let's check the other MH and AT and check it on that again. So we've got, again, a positive slope here, but a negative slope here. So again, not parallel. So if no pairs of opposite sides are parallel, then it looks like it's going to be a kite. Let's look at the let's look at the diagonals and check on their perpendicularity. Alright, so we're looking at the diagonals. So I've got HA and MT, and we're just checking to see if they are perpendicular. So MT would be negative 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4, 5, 6. So negative 6 over 6. And HA, I've got a rise of 1, 2, 3, 4, 5, 6, and a run of 1, 2, 3, 4, 5, 6. So positive 6 over 6. So these are opposite reciprocals. So that means we do have perpendicular diagonals. Now, if you recall, if we're talking about a kite, that's going to be the case. We've got perpendicular diagonals. We also have consecutive sides that are congruent. So let's look at these sides. We've got this, so we've got 1, 2, 3, 4, 5, and 1. 5 and 1, so that means my hypotenuse for my side of my kite has to be the same. And then same thing's going to happen here, which shows that consecutive sides are congruent. So these two are congruent, and those two are congruent. Alright, so last example, we've got 1, 5, 5, 2, 4, negative 3, and negative 4, 3. Alright, so let's look at the opposite sides, the slopes of the opposite sides. Alright, so PQ, we've got a slope of negative 1, 2, 3 over 1, 2, 3, 4, so negative 3/4. And SR, we've got a slope of negative 1, 2, 3, 4, 5, 6, and a run of 8. So that reduces. So these two are parallel. PS, we've got a slope, a positive slope, and QR, I've got a positive slope as well. So let's check. We've got 2 over 1, 2, 3, 4, 5, 2/5. And QR, 1, 2, 3, 4, 5 over 1. So not parallel. Which means that I've got one pair of parallel sides. So that means we're looking at some sort of trapezoid. So let's check to see the legs. If the legs are congruent, then it's going to be isosceles. If it's not, then it's going to be just a typical trapezoid. So we got 1, 2, and 1, 2, 3, 4, 5. And then we've got 1, 1, 2, 3, 4, 5. So these are not going to be congruent, which means it's not an isosceles trapezoid, it's just a trapezoid.